Okay. So heat transfer, we're going to talk about energy associated with physical changes, specifically temperature. So we should, in this is going to be 2 parts. We're going to do the first part today. We're going to talk about heat transfer involved in physical changes and interpret a heating curve and identify the melting and boiling points from a heating curve. So we're going to do these first 3 today, and then we're going to work on the last 2 next class, because this is it's a longer topic. So I'll pause it. 1. So this actually heat curve simulation doesn't work. I'm going to try to find another one. Sorry about that. But melting points and boiling points. They're actually the same temperature. So like water, ice, H2O solid, that melts at 0 degrees Celsius while it's heating. So if you had a pure ice cube at 0 degrees Celsius and you heated it up, it would turn into water at 0 degrees Celsius. If you add liquid water at 0 degrees Celsius and you cooled it, it would turn into ice at 0 degrees Celsius. So it depends if you're heating or cooling, but it happens at the same temperature. Same thing with boiling. Water boils at 100 Celsius, well, if you heat it up. Well, if you cool it down, if you have gas, water, steam, and you cool it down at 100 degrees Celsius, it'll condense, meaning turn into a liquid. So it depends it happens at the same temperature, but it has to do with if you're adding heat or cooling it down, if you're removing the heat. And that's like what we talked about yesterday. So this is the graph of a heating curve, and this is for water. I want you guys to sketch this curve. Yes? So just do a quick sketch of this. You have temperature and heat. Okay? So there are a few points in this graph, and this graph represents temperature on the vertical axis and energy or heat added on the horizontal axis. So this is for water, H2O. Different substances will be different. So if I had like ethanol, it would have a different temperatures at which these occur. Or if I had something like oxygen. Oxygen's a gas, so like oxygen would be much lower in the temperature scale if you had to make it a liquid. So liquid oxygen does exist, it just happens at a much lower temperature. So a common misconception is that the boiling point for everything is 100 degrees Celsius, and the freezing point 0. That's not the case. Okay? Okay. So here, what we do is below 0, we have ice, which is a solid for water, right? Between A and B. Guys, listen up. Above 0 degrees Celsius and below 100, what phase is water? Liquid. So we have liquid water here. And above 100 Celsius, what phase? Vapor or gas. Okay? So these are some different key points here. So we have a couple points here that of interest. Let's see what's we call it. So from this point, from D to E, what's happening? Guys, keep eyes up here, please. Hold on. Guys, everybody's attention. Okay, because I guarantee it's going to be in your homework. Oh. So from C to D, you're a liquid. This is a liquid that's heating. From D to E, however, you start off as a liquid and then you turn to a gas. So this is heating up. As you heat up the water, liquid, you turn it to a gas. You vaporize it. If you're cooling down a vapor at 100 degrees Celsius, you condense it. So this forward, going this way, is a vaporization or boiling. Easy word. And this Going backwards is condensation. So if you're adding energy, if you're increasing the heat on this vertical axis, if you add more, you're going to boil. If you cool it down, you condense. That's at 100. So a couple key points here. See, a similar thing happens with solid. When you heat up your solid, the solid can only heat up so much. Once it gets to 0, when you heat it up, what happens to a solid when you heat it up if it's at its melting point? Melts. And what happens when the liquid's at its freezing point? It freezes. So when you're removing energy from the liquid at the freezing point, it freezes. So our freezing point is a temperature. So this is our melting freezing point. It's the same temperature. It depends if you're adding energy or removing energy. So that's our melting freezing point, 0 Celsius. And our boiling point, our temperature, which this occurs at, is 100 degrees Celsius. It's our boiling and condensation point. So that's a temperature. So when I ask the boiling point, you want to give the temperature. Now, what do we call these changes? Boiling, condensation, melting, or freezing. What do we call those? What type of changes? They are physical changes. Specifically, what type of physical changes? That's true.
Yeah.
What do we call these? What do we call liquid, solid, and gas?
Matter.
Phase changes. So these phase changes occur when the plateau occurs in this, when it flattens out. So it's the two P words, plateau, on the graph. So that's how you can remember it. So you see how it flattens out? You're still adding a lot of energy, but it forms like a plateau. That's how you can tell on the graph. A plateau. Why is that funny? So right now, this is going to take place in our warm-up today. I want you guys to identify the melting point and the boiling point of this substance. Okay? You should be able to tell those right now. It shouldn't take too long. It should. So this temperature. Antonio, Gabby, please. So when we're looking up here, I want to know the melting temperature. It's a temperature. So I'm going to be recording one of these values. I want to know the boiling point and melting point. So I have a solid here, and then I have my plateau here. My solid, it's still solid here, and it becomes a liquid here. What temperature is that? About 1500. That's my melting point. It's 1500 Celsius. Okay? My boiling, here I'm the gas, here I'm the liquid. What's my temperature which that happens?
27.
Say about 2750, 2700.
28.
About 2800?
It's 28.
28? Okay. All right. So about 2800 Celsius. So that's my boiling point right here. So my boiling point about 2800 degrees Celsius. It's 2750. If you had said 2700, basically if you said anything in that range, I'd accept that. And 1500 degrees Celsius is my melting point. Okay? Notice how much more energy it takes to boil something off than it does to melt, because you're really separating those particles. Okay? That's a key thing. Yeah, it takes a lot more energy to move the particles into a gas phase than it does the liquid. Okay? So moving on. We're gonna finish. We'll get to this tomorrow. We'll stop recording now.
Are we done?
Yep, that's it for today. Now for homework, guys.